In this video, I will show you how to create hexagonal nut and bolt, and the nuts and bolts are available in standardized sizes. For example, in metric system, the bolts are available in these nominal sizes, for example M10, 12, M14, 16, and capital H is the head thickness, capital D is the diameter of the body, and this F is the uh, dimension across flat part of the hexagon, and capital C is the dimension across corners, and these are their dimensions, maximum and minimum. We will be using these maximum values for body diameters, for head thickness, area across the flats, and we will be trying to construct one of these bolts, for example M14. And in order to create M14, we first have to create the head, and the thickness of the head is 13.73, and across the flats its dimension is 8.51. So let's move towards the software. So first of all, I have to extrude on one of the planes. For example, if I select right plane and click on extrude, I will be asked to create a sketch, and I have to create a hexagon. In order to create hexagon, I will invoke this palette button, and in polygons I will be selecting six-sided hexagon, and if you double click it and then click somewhere here, so you can move this in the center and press OK, and yeah, close. And you can dimension this hexagon. This dimension is 40. If I delete this dimension, so the strong dimension is now deleted, I am left with a weak dimension. As you can see, this is weak dimension, so it can be changed. If I press this dimension button and first select this flat line, then this flat line, and press scroll, I will be asked to give it a dimension, and its dimension will be across the flats 22 millimeters. 22. Press scroll and select this and move this dimension near it, and then press refit and press OK, Control D, and now I have to give it the thickness. So the head thickness, maximum head thickness is 13.73, sorry, 9.09. so I will use this head thickness value 9.09. so I will use 9, press enter and OK and Control D. So this is how the head will look like, and in order to convert these sharp edges into smooth edges, I will have to uh, remove material. So I will select this top plane and I will be sketching on it at one of the corners. For example, if I select a line, and from this point till this point and this point, and then I use fillet command, and give it some radius, for example 3 units, and then I use this line in order to join this point till this corner and the other point, and using this delete segment I will be removing extra lines. So this is now a closed figure, and again I have to create a center line so that it will be rotated about this line and material will be removed as it is shown in pink shaded color. So now this figure is closed, and if I press OK and sketch 1 is selected, and if I press this revolve and remove material, so you can see sharp edges are now removed. Control D, and one of the sides is now smoothened with sharp edges. The same can be created on the opposite side by selecting this revolve 1 feature and using this mirror button. But in order to mirror it, I have to create a plane first about which it will be mirrored. The thickness of this head was 9 millimeters, so half of 9 is 4.5. So right in the center of this head there will be a plane about which I will try to mirror this revolve 1 feature. If I select this revolve 1 feature and then press this mirror button, the status bar is asking me to select a plane about which the mirror is to be created. So I will be selecting this plane right in the center of this head. So both sides are now, sharp edges are now removed from both of these sides. Control D, and these planes can be in this button. If you press this hide button, planes will be removed. So the head is now created. In order to create the body bolt, I will be selecting this face and then press extrude, and using this center circle I will be creating a circle, and diameter will be selected using this table. So capital D, body diameter is 14 in case of M14 type of bolt. So this dimension will be 14 units, and press OK, and now it can be extruded like this. 46 millimeter, make it like 60 millimeters, and press OK. Now in order to create the threads, I will be selecting this top plane and using this helical sweep feature I will be creating the external threads. So in order to create helical sweep, we have to sketch on one of the planes, like top planes, and we have to create a line like this. So this line will be the reference line for the threads, and a center line about which the threads will be made. And you can also change the length of this line 50 millimeters, and press OK. And now sketch 2 is shown using green color. Now I will invoke helical sweep feature, and on one of the ends I will create profile of the thread. For example, if I create a V type thread, Control D, and press OK, and this remove material. So you can see the threads are now made, but the pitch is actually the distance between two consecutive threads. It can be changed, it can be either increased or decreased depending upon the requirement. I will set it to 2 to make it look like this. If I set it to 1.5, distance between two consecutive threads, I will further reduce it to 1.2. Now I think it is looking good. Press OK, Control D. So the bolt is now prepared. These are external threads. Similarly, in order to create a nut, we have to create internal threads using the same fashion. This is how you create hexagonal bolt. And I can also deselect the plane display and axis display and coordinate system display. So this is how my bolt looks like.